James Webb Space Telescope, or JWST, has done it again. It is peer across unimaginable distances and delivered a bombshell revelation. The strongest evidence yet for an atmosphere on a rocky exoplanet. And not just any rocky exoplanet, we are talking about a world so extreme, the scientists had dubbed it as a lava world. So this isn't just a fascinating tidbit, it is a game changer. The atmosphere on such a world we thought to be nearly impossible. So buckle up, because we are actually about to unlock the secret of TOI 561b. So first, let us know about our star for the show, and rather our planet of the show. So TOI 561b, and this isn't just an exoplanet. It is what astronomers call an ultra hot super Earth. Forget Mercury and a scorching surface, and TOI 561b takes extreme heat to a whole new level. It whips around its parent star in less than 11 hours. And think about that. A year of TOI 56b is shorter than the single Earth day. So this is incredibly tight orbit, means it is constantly bombard its stars radiation, leading to its surface temperature so high that the entire planet is likely a global magma ocean. So imagine world where the land itself flow into a molten glass, and that is why it earned the Soniker lava world. And here is another intriguing detail about TOI 561b. It is ancient scientists estimate it's twice as old as our sun. To a relic, I mean sun, and which is definitely a relic from the earlier universe. So this makes a discovery here even more significant, as it could tell us about how the rocky planet evolved millions of years ago. So now there is where the mystery actually deepens. And for planet like TOI 561b, traditional planetary science dictate that a permanent atmosphere should be near impossible. So why? Because this incredible close orbit definitely is a challenge. When a planet is so close to its star, it constantly blasted by intense stellar wind and radiation, and this powerful energy has a stripped off effect, effectively blowing away any gas molecule that tries to form an atmosphere. So think of a strong hair dryer pointed at a cloud of steam. It dissipates quickly. So the same with the planetary scale, that process in even more efficient, and especially for smaller rocky world with a less gravitational pull to hold into their gases. So for a magma world like TOI 561b, which would outgas some material from its volcanic activity, scientists generally expected any atmosphere to be transient at the best. If it would actually form, then quickly get blasted away, leaving behind a barren, airless rock. So how did the James Webb Space Telescope manage to uncover these incredible secrets? So it all came down to a clever technique called the transit method and Webb's unparalleled sensitivity. So when TOI 56b passes directly in front of its host star from our perspective, a phenomenon called as a transit, a tiny fraction of the star lighter filter through a planet's atmosphere if one exists. So JWST, with its powerful instrument like NIRSpec, is efficiently designed to detect these subtle changes. So as a starlight passes through an atmosphere, certain gases absorb a specific wavelength of light. By analyzing the starlight that reaches JWST during a transit, scientists can look for these telltale absorption pattern, although like a chemical fingerprint. So in the case of TOI 561b, what JWST's NIRSpec instrument observed was truly astonishing. So they detected a temperature around the planet far cooler than expected for a barren, airless lava world. And this significant temperature differences, a drop of hundreds of degrees, is smoking gun. The strongest evidence we have ever seen for a substantial gaseous envelope or atmosphere on a rocky exoplanet. So the gases in the atmosphere are effectively trapping heat, but also radiating it away, leading to a measurable temperature differences. So it's like finding a warm blanket around something you expected to be ice cold, and that blanket is atmosphere. But the revelation don't stop here, and this atmosphere isn't just any atmosphere. The data suggest that the potential for something truly exciting, which is water vapor. So how could a lava world have a water vapor? So it is not liquid water, of course, and instead scientists hypothesis a dynamic cycle. The intense heat would boil elements like hydrogen and oxygen directly out of the planet's molten surface, creating a vapor, and this vapor would rise into atmosphere. But here's the clever part. In this extreme environment, the atmosphere isn't just a gas escaping. It is likely in a fascinating equilibrium. The planet's gravity is strong enough, and the magma a convection current deep within are very powerful enough to continue and replenish these atmospheric gases, including water component, even as are lost in the space. So it is a cosmic give and take, and planetary furnace continuously recycling its own air. So this is a fundamentally different from the Earth water cycle. It is demonstrates how environment we thought impossible for any volatile substance can still hold surprises. So this isn't evidence of habitability, but it is an evidence of complex atmospheric chemistry on the world that shouldn't have any at all, and those kind of surfaces. So what do you think about this discovery and the meaning for our search for life, or for understanding that how our own Earth formed its atmosphere? So let us know your thoughts in the comments below, and we love hearing you. And if you enjoyed this deep dive into JWST's latest incredible find, please give this video a thumbs up. And don't forget to subscribe for a more exciting space news and cosmic exploration, and hit that notification bell so that you can don't miss actually our new adventure. Thanks for watching. See you again. All the best.